Welcome to the Everything Building Envelope podcast. On this show, we discuss topics relating to the exterior building envelope, such as waterproofing, glazing, cladding, roofing, and more. You can subscribe to this podcast on iTunes and Stitcher. For previous episodes, show notes, and bonus video content, check out our website, everythingbuildingenvelope.com.
Welcome, everyone, to our Everything Building Envelope podcast. I'm Bret Taylor, professional engineer, senior consultant 2 for GCI Consultants. I'll be your host today, and I'm excited to have with us Robert Koning, who is the director of the Contractors Institute, Stucco Institute, Building Officials Institute, and is also the developer of the Sealed Cladding System, and he's a consultant in the construction defect industry as well. Today, our topic is going to be the state of stucco. So, Bob, start off, and I'd like you to tell our audience a little bit about yourself, and then we can jump right into the state of stucco.
Well, Bret, I want to thank you for this opportunity to join in this podcast and be part of it. My history throughout my entire adult life in construction, I've really done nothing but that, has been involved in the roofing, waterproof, stucco, and plastering industry. That's been my main forte. Today, my practice is pretty much limited to education and training at the Contractors Institute, and as you said, the Stucco Institute and the Building Officials Institute. We provide examination preparation and continuing education courses for the construction industry. Historically, the stucco industry, as I was part of, that's how I got into construction back when I was after school, 16 years old at a plaster mixer, and have never really gotten out of the stucco and cement plastering trade. Still in it today to a limited degree. But historically, we plastered these houses, we stuccoed these houses. It was a different process then, and we had no problems. Then, circa 2000, through some changes in the industry, or should I say some application of interpretations in the industry, we change things, and then problems begin and are abundant today for a myriad of reasons, some of them related to stucco, but most often they are not.
Okay, excellent. Well, that's an amazing life accomplishment you've got there with all the different institutes and your experience. I'm sure everybody's looking forward to hearing from you today. So let's get right into it. Let's start with a brief history of stucco, just like you were mentioning earlier. About what year did you start, Bob, in stuccoing?
I started in stuccoing back in the late 60s when I began, and as I said, still in today.
Well, that's a good long time. And I'm going to take this opportunity to point out, too, that you were stuccoing in the 60s. It was occurring before then as well. Stucco has been a viable cladding system in Florida, but Florida since then and before then, and continues to be so. And I think what we're going to get into today is some of the items that will cover some of the problems that have come up. Like you said, those don't necessarily mean that stucco is a bad thing. It is viable, and if done properly, it can continue to be viable.
That's absolutely true. When I started in this, I had the honor of being trained by a lot of old-time workers that were in the field. Today, we have the blessing of a lot of men and women working in the field. When I began my career, as you can imagine, it was largely men. There were a few women, but our workforce has expanded, thank God, and we have a lot of new talent. But the old guard, so I'll just simply refer to them as the old guard that trained me, all of their lessons were from trial and error, what did and did not work. And the stucco or cement plastering industry evolved to form a viable cladding that just performed flawlessly. Things were somewhat different then. When we started this, originally the houses inside were rock lath. I began my practice at the era of rock lath. Before that, it was wooden lath strips. But when I got in, it was 3/8 rock lath. And then we would come in and we would brown coat, which is a gypsum plaster, and we would take rods and straighten the wall out. And then we would go outside after the brown coat had to dry, so we moved outside and we would scratch any of the wire around the house with metal lath. Then that metal lath was not galvanized. It was plain black with an asphalt coating on it, sprayed on it, which what we today refer to as interior lath. So it was black lath. It was applied. There was no ribbed lath then. It had been nailed on the wall by the plasters, us, and we used interior nails, which were not galvanized, blue lath nails. And the pattern then was you spread your hand out and you had to have a nail. If you put a nail on your thumb, then you had to touch it with the top of your pinky. That was about the spacing, each way on center. Of course, the back sheathing was either diagonal Reson 1x10 or plywood, and then it was covered with felt. We hand nailed that on, and then we scratched it. The plasters then, I can remember my uncle telling me when I first learned to use a hawk and trowel, they would put the cement on the boards, the mud boards, and we'd make a ring in the middle of it, put a little water in and mix it with your hawk and trowel on the board so that it was a looser consistency or viscosity. My uncle wanted it, all the old plasters wanted it that way, because when you scratched it, you took that cement and you used an up, down, up motion with your trowel. And he wanted to see that cement was so fluid that it would push in through the lath and to the degree it could behind the lath, and you would form like a little river on the toe of your trowel, the toe being the front end, the heel being the back end. That way he knew that it was completely fluid and you were putting a coat on the wall that completely enveloped the lath. His reasoning, I asked him why we had to loosen that mud up, was very simple. He said, I'll never forget it, boy, you can't have any pockets behind this. If you have pockets behind this, you're going to have air. And when you get air behind it, in Florida, it's got salts in it, and it's going to corrode the lath. So that has to be, there can be no space behind that plaster and that lath. And as for the nailing patterns, I asked him, why are we nailing it with this pattern? Even back then, they knew. He knew, because in storms, so that suction pressure will pop that stucco, it'll crack it if you don't nail it at that frequency. So that was the extent that was told to me. Then we scratched that, and then we would leave the job, and we would come back a week or so later, and now it was time to put the white coat inside of the house, which was simply lime and sand. So you scrape the brown coat down, and now you put a thin coat of lime and sand in over the gypsum plaster, and then you moved outside and put your second coat on the wall and densified it. Then we always densified the second coat of plaster, and that's just with a float with a open cell, like a green. Today they're green, but it's an open cell, and you dipped it in the water and you rubbed it. And then most of them were then sand finished. You use a different a white float, and you would sand finish it like you did on the inside. Then all of the corners were rotted. In other words, we didn't use any beads. You held a straight edge, and you rotted that. People who don't know what that is today can go to the Stucco Institute. We have all the photos and the materials there. And then all consideration was given to the painting contractor. We had V tools, and we cut a little V around all of the openings, and you used a paintbrush, like a chip brush today, a cheap throwaway, and you would wet it, and you would go down that V cut to soften the edge so that the painter could use a spatula, and you cleaned the shoulder of whatever it was touching, so that when the painting contractor got there, he simply had to just rub a brush up and down it, or a rag, and he had a good bite or a good shoulder to seal on from whatever the penetration was, pipe or a brick molding or whatever. And the other side of the V, which was in the plaster body, had a soft edge so that his spatula would go down. And the painters then would seal and apply the coating by roller to the proper mill thickness. They would brush all of these V tools, then put their sealant in, and then they would roll the first prime coat, and they would roll the second coat to mill thicknesses of about a minimum of 12, even back then. And they gauged that by the amount of coverage of the paint. And we ended up with a face barrier system that performed absolutely perfectly. The goal of that system then was to ensure that no vapor and no bulk water, of course, and no vapor penetrated through that that would get in behind your system where the felt might wrinkle when the cement touched it. And that system failed. I mean, that system never failed. It was flawless. It's been and it was the one in the Miami code since I've been following the code. Someone told me it went in 1932, but it certainly was in the 50s, all the way up until 2010 when it got removed by the Florida Building Commission with the simple premise they're trying to minimize the codes. And our reference codes today, which are the 926 and the 1063, have provisions unless otherwise specified. So it would allow people to continue following that protocol because of the otherwise specified provision in the referenced ASTM documents. But that got lost along the way, and we started putting systems on for drain plane systems. And as my mother used to say, you can't be a little bit pregnant. You either are or you aren't. The same is true here. Either you have a functional drain plane system or you have a face barrier system. You can't have a little bit of both. It doesn't work that way. And so we've got into some problems in the industry in that respect, along with some diminishing of other aspects such as roofing and painting and sealants and soffit and fascia, which we'll talk about later. So I guess what I would say is that there was a complete lack of understanding circa 2000 in a transition after Hurricane Andrew, when the engineers, rightfully so, became involved in designing load paths. There were people that looked at this then standard, the ASTM 926 and 1063, which are an application standard written by plasters out in the Midwest for plasters in the Midwest when you're using 3-coat stucco with a colored application finish over open framing. And they read that, and a lot of people just didn't understand the difference, so they just said, well, hey, this is the way it should be put on, let's adapt to this, and failures started, and they still are abundant today.
Yeah, that was a great description of how stucco is installed, and I was visualizing it the entire way. As I was visualizing that, I was thinking about the different areas that could be done improperly, that would allow that face sealed system to not perform as you mentioned, and then you can't be a little bit pregnant once you in some way compromise your sealed system. Then you're going to have water coming behind the system, and you're going to compromise the overall integrity. Let's talk about some of the areas that could fail. So you were talking about scoring around the openings. Let's talk about some of the areas that, if done improperly, could let water behind the system.
Well, I'm just going to call it the big three, as of course, the thickness of the coating itself that we put on the outside and the accessories. The two biggest failure points in accessories are plastic or vinyl or metal corner beads on the outside corners and control joints. Those are the big ticket items. Remember, what we're trying to do here, if you think of this, and we have data loggers and tests and data at the Stucco Institute, voluminous materials you can download free. But the concept is relatively simple, Bret. The ASTM documents are very, very good documents, and they were written for an arid region and a lower wind speed. So if you take, first off, the first component in that is metal lath. over a wood frame wall. We'll talk about over block later, but it's a lot simpler over the block. But over a wood framed wall, and you're in an arid region, why it's open framing, first of all. And in some of our training materials, we show the National Weather Service data. So you're in, let's say, Las Vegas or Nevada, and it's 102 average in August, and the outside relative humidity is about 28%. And the rainfall for the month of August is 0.60 inches, less than an inch. And the inside relative humidity in the house is tried to be maintained up around 50 and about 75. So if you just take simple diffusion pressure and you do this concept, you have this wall, and this wall gets wet. It's 3-coat stucco, and the final coat is colored cement. That wall gets wet. First of all, the wall itself in a rain shower in Nevada is going to shield, just simply resist the bulk of the water. It's going to run down the wall. A minuscule fraction of that amount of water is going to get through cracks and separations, and it's going to migrate down behind the system, and it comes out the bottom weep screed at the crack. People don't always understand that weep screed has holes in it. They think those are for water drainage. They are not. Those holes lock the plaster in. It simply weeps. Remember, it's a weep screed, not a drain screed. It weeps the minuscule amount of water that got through at the crack along the bottom. Before we had vinyl, or plastic as most people call them, they're a plastic-based material. Before we had that and we had metal, we had to wax the top of those flanges so that the lime wouldn't bind into that and block that ability to drain at that crack. So this standard was written again with using lime and sand and cement. There was no premix type X then. So the water would be shielded by the wall, and some would get through. The vapor never really wants to permeate through, and the reason of that is the relative humidity is lower outside than it is inside. So when the rainstorm stops, immediately you go back to 102, you're back to 30% relative humidity, and the wall dries to the outside very, very rapidly. So it's really hard to get any long-term or chronic moisture problems in a wall out there. It gets wet, it's very incidental, everything is trying to dry to the outside and drying to the outside. Now, if you move that scenario to Orlando, Florida, where the average August temperature is 94 degrees, the relative humidity is 86%, and the average rainfall is 7.5 inches as opposed to a half an inch. Now you are just simply flooding that wall with water on a fairly constant basis. The outside humidity, of course, is above 90%, and it's 100% when it rains. The inside is being maintained about 55, so all of the water and all of the vapor have a diffusion pressure to move inward. So let's assume that the rain stops and the relative humidity stays in the 90s for a while. It might get back down to the 80s, but it stays high. And now all that vapor does not dry to the outside. It is pushing to the interior. There was a time when we used felt and we had laps on the felt, and that vapor could migrate through, and then it would encumber either wood planking or it would hit a plywood sheathing with a perm of about 12, perm ratings about 12, and could pass through and be dehumidified into the system. Before air conditioning, the inside and outside were stable, so you didn't have any difference in diffusion pressure. So now we're moving. Well, with the advent of OSB and house wrap, the house wrap, at least Tyvek, normal house wrap, the perm rate is in its 50, even stucco wraps around 20. That vapor moves through the house wrap, and now it encounters the OSB in its movement inward. Well, the OSB perm rating is 0 to 1. It has a silicone coating on it. And so it stops there. And it just remains there behind the stucco system in mass. And then at nighttime, when we have the radiant loss to the nighttime black sky, the wall cools below the condensing temperature by about 10 o'clock at night, and that vapor condenses behind our system. And then we keep that cyclic. We've painted the house with the outside with paints. We measured 74 houses in a recent study. The average mill thickness was 3. Remember, it should be 12. So the vapor passes right through, but now there's no returning force. There's no difference in diffusion that's trying to get it to dry out. It's still wanting to go to the interior of the house. And to make matters worse, we have a weep screed down at the bottom, and we've painted the crack. You can't let the water out now because this stucco system, as it's contemplated in 926, well, everybody understands, was never meant to be painted. You have to do other accommodations with your termination points. So now we have the wetting, continual elevated relative humidity behind the stucco system, behind the tieback, the tie par, and now we get fungal growth. And once we initiate that, we have problems. So that's a first huge problem. Second problem we have is the attachment of the lath. The standard was written in a low wind speed region where straight line winds then were 90 miles an hour. And they said in the standard to put the fasteners of the metal lath 7 inches vertically up the studs, which are spaced 16 inches horizontally on center. And that's fine, that works well. We don't fail in withdrawal. But what happens in a higher wind region where the wind speed is over 115 miles per hour V-alt, or the wall pressure is in excess of about 28 pounds, then what happens is the fasteners don't fail in withdrawal. The stucco literally in between that 16-inch space bows outward from suction forces and cracks. If you think about it, if you in a high wind region and you space 16 inches horizontally on a 8-foot high wall, that's all of that area. I think it's over 10 square feet. All of that area is now with no fasteners. It's unrestrained. And so you can see the flexure of the stucco is great. That's why we get a lot of cracking. We didn't have that in Miami-Dade, and the reason is Miami-Dade always required 2 fasteners per square foot, which means you have to put a row in between the vertical framing members. One of the misunderstandings fundamentally of the text is, why is it on the vertical studs? And why is that important? Because the standard was written for open framing. Where else are you going to put the fasteners? In open air? There's no other choice. Even when the standard talks about sheathing, it's talking about non-structural sheathing, such as styrofoam or homosote or asphalt impregnated sheathing or thermoply, any of those that is done everywhere in the United States except here in this high wind region area. So it says that now you understand, if you take those 2 precepts, you understand over open framing why the standard says in between the studs you have to tie the lap of the wire with tie wire. You have to tie the laps of the metal lath with wire, 9 inches in between the studs. And when you butt one sheet to another of metal lath and it's not over a vertical framing member, like in between the 2, you have to lace wire in between the 2 sheets. Well, of course, if you didn't do that, when you ran your trowel of mud up the wall to scratch it, your hand would simply go into the middle of the wall cavity. It makes perfect sense when you understand why those things were written. For instance, the increase in nail length to accommodate the sheathing thickness. Well, of course, let's assume that we're in Arizona. I show one in class that was actually done just a year or so ago in Arizona. And there's 3/4 inch styrofoam put on the outside of the studs. Well, if you didn't, and there is nothing else, so you had to nail the lath through the styrofoam and into the stud. If you didn't allow for add the thickness of that styrofoam to the required length of the fastener, well, the stucco wall would fall off. Of course you have to do that. But here in our high wind region and around the Gulf Coast and in Texas and up the East Coast to a degree, we require structural sheathing on the outside of the wall. Literally a structural sheathing, rated with a stamp for structural capability, and meaning it has withdrawal value. When you cover the wall with a structural panel, the whole wall is the framing member. So you don't have to go find those studs. For instance, the roofer doesn't lay a shingle down and then say, okay, I'm going to increase my nails, and I'm only going to put the nails through the sheathing and into the top of the trusses, and I'm not going to nail in between the two. You see the fallacy of that. So those things, that cracking has led to a problem because of the weakness in our fastening patterns. Then the accessories are a problem. The plastic corner beads were originally made for block. They weren't made to go on stucco. You have to fully encapsulate them with plaster. And it's hard to do that. On a block wall, it's not as hard because it's right tight against the block corner. In other words, the thickness of the bead itself, if it's pushed tight against the wall, forms the ground for the thickness of the stucco. But when you move those up on a frame wall and you're trying to bump those out 7/8 of an inch, which people do, not interpreting the standard correctly, and that is 3/4, and the standards say that. Now you have huge pockets behind that. You can't get them full. And then the beads crack at the corners. That's what they're supposed to do, sacrificial. And the water gets in that cavity and fills up and just has caused billions of dollars of damage. The control joints likewise have to be integrated properly, and it would take more time than we have to discuss the different ways to accomplish that. But sufficient to say that recent tests by 2 agencies tested the corner bead the control joints every way you could install them. Attached, not attached, tied, attached one side and tied on the other, behind the metal lath and top of the metal lath, every way. And there was no meaningful or measurable difference in the crack patterns, regardless of how they were put on, including the panels that had no control joints at all. So people don't have lost a concept of what these control joints meant to us in the industries and why they were used, especially over concrete block. Well, if we'll shift now to a block wall. If you were to remember, the standard is for colored cement, and that's always 1/8 of an inch, the final code. It's not part of the system, it's the color code. The standard says so. So if you were to put 1/8 of an inch color coat directly over block, when it dried, you would see every horizontal block joint and every lintel and every downpour, because unless that colored stucco dries at the same identical rate by suction, then what dries quicker dries lighter. So we have to put a base coat over a block wall. And that base coat has to provide a uniform suction for the color coat. So we require over block a 3/8 base coat, leveled out, densified, and we let that cure so that when we put the color coat over it, all the suction is uniform into that 3/8 base coat, and you'll have a nice, pleasing color all down the wall. Now, we can't do that without that base coat. Now, if you think of the second problem with the base coat and go back in time, we were actually using cement and lime. And then we would use white cement and lime and use buff if you wanted a light cream color. If you wanted darker, we would use a half a bag of white cement and a half a bag of gray cement. You could mix that. So you could change your base, you could change your color coat to whatever you wanted. So now think of this. Go back to the base coat, and we're applying gray cement and sand and lime. And I'm in the middle of the wall, and I'm what we call running top. So I am up on sawhorses at the top of the 8-foot wall, bringing it down to 4 foot. And my key mud runner is working beside me, and he's running the bottoms, but he has to be over to the left because I'm standing on sawhorse or scaffold here. So there's a Z-type zigzag in the wall. We run out of base coat. The labor brings a new batch from a new mixer load and then mixes it. And we start running it on, and we don't see any difference with our eyes. But the mix had been mixed 5 minutes longer, and the line began to air and train. And he used a few shovels more sand. What we don't see is the fact that we've changed the suction properties of the base by that air and training of the lime and that change of the sand. It's minuscule. You don't see it at this point, but when you run the color coat over it, you'll see that Z-type change in color in the wall. So to alleviate that, we put these control joints right down the wall. They control the thickness and they control the density for the color coat curing. And we fill those in. And the reason of their 144 square foot placement is because if you take 144, the beads were originally a ½ inch thick, and you multiply 144 square feet times a half divided by 12, the answer is 6 cubic feet. That's the size of a standard stucco mixer. So that one mixer load would fill the area of 144 square feet, and the next mixer load would go into the adjacent one. And when there's a vertical break, you won't see if there's a slight minuscule change in color. You only see that if they're blended. So by then extending those up into the frame wall, which serves the same purpose for controlling those areas, if they're not integrated properly, hence the papers put over their flanges, and the flange and the metal lath do not become one by pushing the mud through them, then the water that gets in along their vertical crack line will go right behind the paper, and that's the worst place to have it. So those are the big three right there. First of all, the lack of the required face barrier. If you're going to paint it, you have to coat it. You don't get to just spritz some things on and change the color. Number two, you have to anchor the sheet correctly, and that requires at least 2 fasteners per square foot. It always has. And then accessories should be considered on residential homes with 8-foot high wall. The vertical ones should be eliminated. Most consultants agree on that. If you don't, you can put them in, but you have to make sure they are put in carefully and correctly. And corner beads should not be used. You should rod the corners with we call it a stick. It's a magnesium L-shaped piece of metal. It's just a straight edge, and one person holds it, and the other builds the corner so that the corner is solid cement. If you do those things, you eliminate, a lot of the problems we're having. To just expand quickly on that, the stucco contractors faced with a dilemma. We have a lot of problems where the soffits are being run and they're not pitched back uphill. When I started in the trade, all of the overhangs were 2 feet. Now we've moved them back, to a foot, 6 inches. The wall gets a lot more water that way. But what also happens is that the soffit, when we change from a square cut fascia to a plumb cut fascia, meaning it's vertical up and down for the ease of putting gutters, the water runs down that face, comes off the roof in mass, runs down the face, turns, because the old fascia we use in wood, we made sure that's stuck down at least 3/4 of an inch. The new fascia is just an L shape and it wraps around. The water will run literally back the soffit if the soffit is not tilted upwards towards the wall and get behind the stucco. Additionally, the edge metal, if it's not bent by the roofer when he's put on in a sheet metal break, remember that when you go to the store, any roofing supply or big box store, and you buy it, it's at 90 degrees. It's meant to go onto a square cut fascia, not a plumb cut. If you put that metal on a plumb cut, you have to put it in a break and change the flange angle. If you don't do that, the metal creeps back up forms a flat spot on the shingles, and this is ubiquitous. There are class action lawsuits all over this. The water then gets on the shingle and travels laterally instead of continuing off the roof, leaks, goes in behind the subfascia to the bottom of the soffit, runs back to the wall, goes behind the stucco. So those problems abound, and they are probably at least a third of all problems we see are related to the soffit or the roof. And we'll include in that the 4x6, what we normally say is a kick-out flashing. That intersection of a horizontal soffit and fascia into a vertical wall that's higher, builders have said in desperate futility to say, I'm going to slide a piece of waterproofing membrane in between where that fascia hits that wall. All you're doing is moving the wrought area down 18 inches. You solve nothing in doing that. That interface has to be watertight. And the problems almost exclusively are in the 4x6, to the point that we're developing a newsletter now to just remind roofers this is how you're supposed to make a transition. Let's call it a kick out. Most people will recognize that, with tongs that hooks on that will be watertight. If you don't do that, if you just use the metal over the top, it's going to leak and it's going to rot the wood behind it. And we know that. We've known that in the roofing industry for decades, and yet it still is not done. And when you see it done, literally a sixth grader could do it. It's not difficult, but if it's not shown, you don't know. And that's, of course, probably the biggest is a lack of vocational training in our industry.
Absolutely, Bob. And I could listen to you talk about this for hours. There's so much in what you said. There's a lot of detail, and of course, the devil is in the details. And you were covering this at kind of some locations, a very specific description in some areas were the 30,000 foot view, which I find, very interesting. Hopefully people are following along with some of that. We could kind of break this whole conversation into probably several different podcasts, but
right.
You're right. I mean, it comes down to some of the basics, which are attention to detail, proper installation, and some of the key points you focused on were the paint, the proper attachment of lath, and the proper installation and use of accessories. In other words, just because they exist doesn't mean you should be using them in certain locations.
And we did, Bret. We put all these details, non-proprietary, in CAD files that you can download at the Stucco Institute free. Now, the Sealed Cladding System, we went in and to the laboratory, the accredited laboratory, and got all the ASTM 330, 331, and the E74 tests done on the models, and got a Florida product approval. And people say to me when they use it, they love it. Well, thank you for inventing this. I didn't invent that. That system is identical. It is the Miami-Dade protocol that was in the Miami-Dade code that was, let's just say erroneously for not valid reasons, taken out. So I just redid the Miami-Dade code, which I had plastered under all my life, and took it into a laboratory and got it. And although that does mention materials, I don't want to mention any materials by brand name. You're free to substitute. You can use any. For instance, your waterproofing coating, you could use Behr, you could use Color Wheel, you could use Sherwin-Williams, you could use Drylock. You can use whatever you want as long as the properties of the waterproofing are met and they're online. You do as an engineer and architect does approve equals. Just substitute whatever you want. And it's any brand of type S mortar. So the CAD details are there so that, including the roofing and the flashing details, so that you don't get lost. There is a place you can go, at least in our estimation. These are the old details at work. Here they are. They're free.
That's good to know. And like you said, these are time tested, and for whatever reason, we went astray for a while, and it looks like we're going to try to pull people back towards what's going to work. And we also have to focus in on the fact that, proper application of your coating which is what we're talking about here, face sealed system, is key. You can't put down 3 mils and expect it to work over the long term.
Right.
And then the other piece of that is the maintenance. I mean, we have coatings on there specified at 12 mils. That should get you a pretty decent life. But in Florida, after several years of the heat and the intensity of the sun, you still need to recoat your system after 5, 7, or so years, depending on the product that you use.
That is correct. It's very important that you realize that in Florida, with a face barrier system, any crack over a hairline needs to be addressed. It's not like where we see all these crack gauges and comparisons that were written for colored stucco, what is and what is not acceptable in the width of a crack and the number of cracks on a system that's going to be subject to rainfall amounts of 0.6 of an inch a month and has an outside relative humidity of 30. You cannot apply that same thought process to Florida with a rainfall of 7.5 inches in that same month and an average outside relative humidity of 85% and inside of 55%. Those cracks will let more water in than the system can manage, and the results can be disastrous. So I tell my homeowners, look, after every high wind event, you should walk around your house, use a binoculars or a monocular or anything, and look carefully. If you have any cracks, you see a crack, get your painter up or your coating or you get up on a ladder and simply brush some replenishing coating in there to bridge that. Hairline's okay because they'll close up, but you can't allow 1/8-inch cracks in the stucco system and survive in Florida.
Even a minor amount of water intrusion can add up over time. And then kind of pulling this back a little bit and help people understand better, the concept of vapor drive is it's going to go from hot to cold, high humidity to low humidity. So the water in the air will drive through a wall, and depending on the perm rating of that wall construction, it will drive it into your home. That's why you have to continually provide dehumidification of the interior of your house. If you don't, the humidity will build up on the inside and you'll have mold and mildew issues. So
that's correct.
That's why if you go outside and look at your HVAC condenser, typically there'll be a pipe near there that will be dripping water constantly. That's the water being pulled out of your home, and that water comes in through opening doors and windows, but also through vapor drive. So if you do have that hairline crack in your stucco and or your paint, that vapor drive will occur, and if you allow it to continue over a long enough period of time, you're going to degrade your cladding. So another kind of analogy to put out there for people is if you've ever seen petrified wood that was pulled out of a lake or a river, if the wood is underwater and has no access to oxygen, it can't rot. Similar sort of concept. If you don't let water affect your stucco and the lath that's embedded into your stucco, then you shouldn't have any corrosion issues as long as it was installed properly. So it's really key to maintain that coating over time and or the cladding and coating in general.
That's so true. Every word is true. We took a building. I had requests from several engineers, friends of mine, and they were across the nation, and they just were confused, dumbfounded at this old methodology. What do you mean you didn't put control joints in? And what do you mean you didn't put weave screeds in and you went from wooden frame and brought the metal lath right down over the block and stub nailed it in and had one continuous coat? Why, that'll crack, and you have no crack relief. And so finally I said, well, you know what? I've got a building I did 35 years ago. It's in a coastal region. I have photographs here of it being stuccoed 35 years ago. It's with black, ungalvanized metal lath. It was attached with standard staples. There are no control joints in it. There is no horizontal weave screeds in it. It's one continuous coat of stucco from top to bottom. And just like the Miami-Dade protocol, the thickness over wood is 1/2 inch. It's not 3/4. It's not 7/8. It's 1/2 inch. And I did it 35 years ago, and it has been painted in that 35 years twice. So let's go cut it open. And we did, and I put it all online, 35-year-old stucco system, performing perfectly with no control joints, no weep screeds, and only a half an inch thick with ungalvanized metal lath. So we cut it, and all the photos are online. I said, you told the guys, you tell me where you want it cut. And we'd cut it and look at it, and Bret, it looked like the day that I put it on 35 years ago. We took the photos and said, it looks identical. There's no rust, there's no nothing. But the first time when we coated it after we stuccoed it, we properly sealed around all the penetrations and we rolled. Nothing special. We just followed the instructions on the can to the required coverage per square foot, which is generally you're going to get about 100 square foot, 90 square foot out of a gallon. And you do that 2 times, and that's what we did. And it's remained flawless. So, as you know, as an engineer, more so than I, things are predictable. Stucco, plaster, and cement behaves the same way if it's done the same way. So why would it behave this way on this building and a different way on a different building? And that's because of the coating and the details that were not done on the other building. Moisture passing through the system and condensing behind it is not good, as you just pointed out.
Right. Yeah, maintenance, design, installation is obviously potentially an issue in any construction, but certainly proper integration is key. Maintenance is key. It all works together. There is no one thing that's the problem, and I think that's a pretty good segue right now. I wanted to talk a little bit about, in the last 5 or so years, there has been some stucco litigation that has occurred. And I wanted you to touch on that a little bit because, in my mind, I think it's maybe the easiest thing to see as an issue was the stucco being the problem. And I know that's not the case. I think it's a combination of all the things we've mentioned that, for whatever reason, just weren't working, and someone wanted to point the blame towards stucco. Can you address that?
Sure, and that's you hit the nail right on the head. Somebody had to point their finger. Now, if you look at the reasoning behind that, 40 years ago, 30 years ago, if you called an engineer out and you said, I have this problem, the engineer would set up diagnostic protocols and say, okay, we think this is it. This is our hypothesis. We think this window is leaking. They would set up protocols to seal around, to test the window. They would find a leak. Then they would install a repair protocol, do that, and then retest it and validate it and say, okay, look, although it may not be happening, we're going to extrapolate that to these other windows or this other condition, and let's just get it fixed. The goal was to get it fixed. In today's litigious societies, there are evaluations that are being done not to analyze or determine what is the problem and what is the solution to fix it. It is strictly, how do we document the largest potential violation, whether or not those violations are in any way related to what the alleged harm is, so that we can proffer the greatest amount of damages. From the legal side, there is a percentage that goes to the legal team, so the higher the recovery or damages, the more they make. And the ease for the person doing the evaluation is cut and paste, and charging the fee. Then they get money on what we call the back end of that, when there's expert witness, when the defense, the contractor and the stucco contractor's attorney has to depose them, they charge huge fees for that. And that's just part of the process. But the people that involved is sometimes concerning. A lot of these lawsuits are born from a violation of Florida Statute 553 that says if anybody violates the building code, then you have any person injured by that basically has a right to sue that person in court, whether there's privity or not. The old way, if the owner couldn't sue the stucco contractor because he had no privity, he had to sue the contractor, and the contractor would then enjoin. And that's still done today, but this gives an owner a direct route at anybody if they violated the code. That's only done, to my knowledge, in Florida. None of the other states do that. So here's what happens. Well, if we can say the stucco is installed improperly according to a reference standard, even though that reference standard may be interpreted different ways by different people, and even though it may allow that by its provisions of unless otherwise specified, I'll go ahead and state it as a violation and it has to come off. Well, wait a minute, what about the paint? Okay, why don't we sue and the painter? Well, you remember, they're suing under 553, a violation of the code. Guess what word doesn't exist in the code? Paint. There is no requirements. You can get a CO on a block wall with no paint. You can just get a CO on bare blocks. So they can't bring that person in. And if you think of the stucco over the frame, most insurance companies, well, all insurance companies say to contractors, we're not going to pay for work you did incorrectly. So one would think, well, if the stucco man put the stucco on incorrectly, the insurance isn't going to provide any money. But there's what's called a rip and tear doctrine. If we can say that the stucco damaged something else and we have to now remove the stucco to fix what was damaged, then the insurance company has to cover it. It's called a rip and tear doctrine. So now we'll challenge the spacing on the sheathing. We'll challenge the ability of the staples to hold now that the water's been in there, so that we invoke the insurance coverage. Now, ironically, if you think of this is, and I want to say this so that I don't want to mention anything specific, but let's say that I am a builder and I am sued by somebody who said my stucco was bad, my weather wrap was bad, my flashing is bad, my windows were installed incorrectly, so on and so forth. And so I'm sued for that. Well, what my attorney will do, my insurance company, will simply enjoin those other subs. And so let's say we have 5 subs. Each one of those attorneys for those 5 subs knows that even if they had a crystal ball and could guarantee that they would win on a jury verdict, even if that were true, they're going to go out of pocket probably at least $15,000. They're going to have to, the insurance company's going to have to pay the lawyer. They're going to have to attend the depositions. They're going to have to pay for the transcripts of the depositions. Then they're going to have to go to court and be part of the process and get the verdict. So even if that verdict was guaranteed to come back not guilty for the stucco guy, the out-of-pocket expenses to the insurance is at least $15,000. So, and that's true for every sub. So now as a builder, I have 5 subs. I'm looking at the owner who says this is $60,000 in damages. So I go to my 5 subs and I said, look, it's going to cost you $15,000 to get out of this. I mean, it's going to take you $15,000 to defend this, even if you get out not guilty. So look, why don't I take the risk out of it? You give me $10,000 and I'll let you out. So I go gather up $50,000 from my subs. And now I go back to the plaintiff's lawyer and I say, listen, you say it's $60,000. Our experts say, no. It's not $5,000 worth of damage. And we banter back and forth. Then I say, look, I'll give you $40,000 and you walk today. So they take the $40,000 and I just collected $50,000 and sometimes $60,000 and $70,000. I make $10,000 or $15,000 off of the deal. So it's not really a big heartburn to me as the builder. So that has been happening, and the problem is the insurance companies now have started raising the rates, and the cost of construction is going higher because of it. Some of them aren't even going to insure the stucco contractors and the house wrap contractors. So it's the mess that created we're now dealing with in a higher construction cost. So people now are saying, hey, let's stop playing this game. Let's find out what's really wrong and let's get it corrected. And many builders now are setting up and taking heed and taking a proactive stance to say, look, we don't care what your expert says. This is what we'll do to your house, and we'll do it free of charge. And most people will take that because it really will correct their problems in most all cases if they just properly clean, prep, and coat the building and seal it up again. It's really a no harm, no foul in many cases.
Well, Bob, that's a great segue into the last question, which is, what do you recommend we do as an industry to help improve the conditions on the ground for everybody, but obviously to promote stucco, which is, it's kind of a icon of Florida, I think. I love the material. I like the way it looks. It feels good. It provides soundproofing, looks good. So what can we do as an industry to help get us past this time and improve the quality of stucco?
Well, if you would have talked to me a 3 months ago, I'd have probably given you a different answer. And the reason is simple, that our legislature just passed a law repealing all of the local competency card categories in 2023. That's the final date. So that means that we are heading to a date when there will be no requirement for a stucco contractor to be licensed, or a tile setter, or a framer, or a trim carpenter, or any of those trades. They will be able to work without licensure. And that's going to present another level of problems that are going to be coming at us because of that. So the answer would be to look, let's get better training to the workforce. Let's do that. Let's work with vocational education, which I think everybody's on board now. Hey, we need to reinstate this in our schools. But, you can go to almost any school and find a plumbing, electrical, or mechanical course. Those are what we call easy peasy there. But where do you go to learn to be a block mason? Where do you go to learn to be a stucco contractor? So we need to figure out a way to get these in the vocational schools, number one. Number two, we have to increase the licensure requirements. Let's increase the requirements to get a stucco contractor's license. Let's develop a real and accurate competency test so that they know how to put these systems on and understand weatherproofing and waterproofing as a whole rather than just their little segment. So we need to increase that. So that's all we can really do unless there was some major change to where insurance, let's say, were no longer, they've talked about this, no longer to become a requirement for subcontracting trades. Well, now a builder is going to say, not all builders do this, so I don't want this carte blanche, but some builders only look at the bottom line price they get, and whatever's the best price is what they're going to take. They rely on the fact that that subcontractor has insurance, and they make them sign an indemnity agreement in their contract to indemnify them, so they really have no exposure. If that were removed and subcontractors were not required to be insured by law, then the contractor might say, listen, it's not a matter of money. I want to know that you do your job right, and when you leave my job, I don't have to worry about suits. So from my classroom teaching, those are the three variables that we get. Increase the training in VOTEC, increase the minimum criteria to get the license, and thirdly, eliminate the requirement for subcontractors to be protecting or indemnifying the general contractor. Let the general contractor carry his or her own insurance and let them negotiate and find the best subs. I don't know if that's the answer, Bret, but that's what I hear from the people in class the most.
Sounds like a good start to me, and I want to kind of go back and circle back to what you said earlier as well. The recommendation would be, I think, what we can do today on the ground is make sure you pay attention to the devils and the details, because it is. Make sure you detail around your penetrations through your wall properly so that you can apply a proper sealant bead, apply the proper mill thickness of your coating, make sure your accessories are installed properly as well. But basically just focus on quality workmanship. But key in Florida is ultimately for a sealed cladding system, you have to do the sealant and paint properly. Otherwise, you're going to have areas that are going to be compromised because cracks open up in different areas, whether it's accessories or in the stucco itself, and that's going to allow bulk water to come behind your system.
Very well said.
So, Bob, wow, this has been really a great talk today. I appreciate you being here. In closing, I want to thank everybody else for listening today to our podcast. Bob, if the listeners want to reach out to you and your team, what's your website address and what's the best way for them to contact you?
You can reach me at the contractorsinstitute.com. Just click instructors and my picture and email is there. Or stuccoinstitute.com is the same. Or I have a direct email. It's Robert K., just ROBERTK at Koning, KONING.com. That'll come directly to me.
Okay, thank you, Bob. We'd also like to invite the listeners to take a further look at GCI Consultant services at our website, which is GCIconsultants.com. You can also reach us at 877-740-9990, and we can discuss any of your building envelope needs. I want to thank everybody else again. I look forward to talking with you the next time on our Everything Building Envelope podcast.
Thanks for joining us today. Please subscribe to this podcast on iTunes or Stitcher. For more information on the Everything Building Envelope, previous episodes, show notes, bonus video content, and much more, check out our website, everythingbuildingenvelope.com.